Hi, I'm Jeremy, the Zoo Nerd, coming to you live from my backyard in beautiful Los Angeles, California. How's everyone doing today? I hope you're well, I hope you're happy, I hope you're healthy, I hope you're being safe. It is nice and toasty today here in LA. Current temperature is 95 degrees, so I am staying in the shade during this critter chat. Today we're going to talk about a very important animal that's little tiny, or most of them are tiny, but they do some very huge things. Today we're going to talk about coral. Now, for starters, coral is an animal. Sometimes it looks like a rock, it feels like a rock. Some people may think it looks like a plant, but it is indeed an animal. It's actually a lot of animals that live really close together. In fact, coral builds its home, and then many other animals move in around it and live around the coral reefs. It's estimated that about 25% of all ocean creatures live in and around coral reefs, although coral reefs only occupy about 1% of the ocean floor. So coral animals are little tiny guys. Most of them are just barely visible. They are called polyps, and they are a soft-bodied animal. They don't have a skeleton, and they have stinging cells. So they're kind of they're related to jellies and sea anemones, and they kind of have a similar structure to a sea anemone. We'll do a separate episode of Critter Chat on sea anemones coming up. But they're little tiny, squishy, soft-sided animals with stinging cells and tentacles that surround their mouth that come out at the top. But unlike those others, coral animals, the little polyps, they build a harder home around them. And they build that through a chemical process called calcium carbonate, and that gives them a nice hard outer structure that protects them, kind of like a turtle shell can protect the turtle. But as they build those little homes, it's kind of like an apartment building. And many little polyp animals live very close together in something that's only this big. Kind of like a very crowded apartment building, and each little hole in there has a little different animal in it. Now, if you've ever seen coral, especially if you've seen it out of the ocean, it's usually white. That's no longer living, there's no longer animals in it. We'll talk a little bit about how that all works in a moment. The little animals that live inside those rocky substances, though, the little polyps, they can range in size from a pinhead, little bitty tiny, up to about a size of a basketball, being almost a foot across. And they are all kind of similar anatomy, but they vary quite a bit in size, color, and function, and how they kind of exist, and what their outer homes look like can vary quite a bit, species to species. Now, there's many different coral species. I don't know how many. Hundreds, if not thousands, for sure. There are new species of coral always being found, and we're finding them in places we didn't know coral lived. So it's a fun and exciting thing to continue to learn more about coral. Now, the little polyps themselves that live inside this rocky-like substance that they build, they're translucent. That means they're almost clear. You can kind of see a little bit of their structure, but you can almost see right through them. But coral is known for being very colorful. But the color doesn't come from the animals. It comes from a special kind of algae that lives inside the structure of the polyp itself. It'd be like if we had lettuce growing out of our arms. This algae is called zooxanthellae. It's kind of a big name. It's kind of a crazy word. But it's a very specialized algae that has a symbiotic relationship with the coral polyp. That means they live together and they both benefit from that relationship. So the algae has a home, a place to live and to grow, and it helps provide the coral with a lot of the food that it needs. Now, the coral also has some stinging cells and can catch some of its own food, but most food from coral comes from the algae that lives inside of it. And the color that we see when we look at coral all comes from that algae as well. So sometimes coral loses its color, and that is called coral bleaching. We're going to talk a little bit more about how and why that happens in a minute. But when the coral bleaches, it kicks the algae out. It says, hey, I'm under stress. I need to take a minute to refigure out life, and you've got to go. And so it kicks the algae out and it loses its color, becoming very white. That's called coral bleaching. It does not mean that the coral is dead. Not yet. Sometimes it gets to that point. We'll talk a bit more in coral bleaching in a minute. Now, coral typically lives in tropical waters. It lives in warm places. That's where we find the big reefs. That's where we see most of the species of coral. But it's not the only place. Yesterday I talked a little bit about a special marine national monument that's in the Atlantic Ocean that is currently being evaluated and threatened by our current administration. But in that very special Atlantic National Monument, there's some very deep sea species of corals that live there. They live in really deep water. And that's a new group of coral species that we're still learning a lot about and how they live, because they don't have the sunlight that many of the tropical species of coral use to help their algae grow. Those deep sea corals we still don't know much about, and that's why protecting them in that place like the National Monument in the Atlantic Ocean is very important, so that we can learn more about them and how they function and live. Now, like I said, most coral lives in tropical waters. If you've ever been to a tropical location, you may have seen that even just flying over in an airplane, or if you've been to a beach in a tropical area, you've maybe seen that from standing on the ground and looking out. You can see some of the coral reef from the shore. The largest of all coral reefs is the Great Barrier Reef, and it's off the coast of Australia. Sorry, there's a lot of construction in my neighborhood today. 2 different neighbors are doing projects, so sorry if there's noise from that. These tropical reefs, this Great Barrier Reef in Australia is over 1,200 miles long. That's as far as from here, where I am in Los Angeles, to the middle of the country of the United States in Lincoln, Nebraska. That's how big the Great Barrier Reef is. And in places, it's about 30 miles across as well. There's over 900 islands that exist in and around the Great Barrier Reef as well. The Great Barrier Reef is considered one of the 7 natural wonders of the world, and it's a UNESCO World Heritage Site. So that means that aside from Australia protecting it, other organizations and other groups have also said we need to protect this area. It is very unique and very special. It's the only living thing you can really see from space. The astronauts have reported and taken many photos of the Great Barrier Reef over the years that we've been exploring space, and it's a very exciting thing that it's that huge. In addition to being so huge, it also has over 400 species of coral that live on the Great Barrier Reef, with 1,500 species of fish, 400 species of mollusk, and 200 species of seabirds, in addition to sponges, giant clams, dolphins, sea turtles, snails, and many more types of animals live at the Great Barrier Reef. And there's other big coral reefs and other big areas of coral throughout much of the tropical area of the world, the areas near the equator. And many of those offer a lot of diversity, or a lot of variety of different types of animals live in and around them. So it's a very important ecosystem in the ocean. There's more species that live in a coral reef than any other portion of the ocean. Scientists say that it rivals the rainforest in the level of number of species that live there. It's estimated that there's over 2 million different species around the world that live in a coral reef setting. So it's very, very important for biodiversity, or the number of variety of species that live in such a unique place. Coral reefs also have a huge benefit to people. Over 500 million people live in areas near coral reefs, and they rely on the fish that live at the reef as a main part of their food source. So over 500 million people rely on coral reefs for their food, for the fish that they eat every day. In addition to that, coral reefs provide a huge benefit when there are big storms like hurricanes that start out over the ocean and come twirling towards the land. When there is a coral reef in the way, it helps to really slow down the storm and helps break up some of those big waves that would otherwise destroy beaches and many of the communities that live right along a beach area. Places like Australia with the Great Barrier Reef, if they're a city near the reef, they do a lot better when a hurricane, or what they call a tropical cyclone, happens in the area with the reef. In addition to that, coral reefs are being studied and implemented into many kinds of medicine. There's so many animals that live in a coral reef, and so many crazy science things that go on with photosynthesis and regeneration, and corals that can break apart, but then both pieces survive and grow new colonies of coral. And all of that is helping scientists learn new things about how cells grow, how cells divide, how we can use things from coral and other ocean animals to help us study medicine and learn new techniques of treating a wide variety of diseases and other ailments that people have. So it's very, very important that we continue to learn and grow and protect the coral. Now, coral, they're little tiny animals again, building these rock-like homes that they live in. They grow very slowly. So most coral species, their coral home, their like rocky looking substance, only grows about an inch a year. Some species that look more like a tree and have more branch-like things can grow a little faster, maybe 6 inches a year for the fastest of growing corals. But that also means that if we do harm to the coral, it can take a really long time for it to come back. Many of the big reefs, like the Great Barrier Reef in Australia, have been growing in that spot for millions of years. And most reefs or corals that we see when we go visit places like that are at least hundreds, if not thousands of years old. Slowly building, and then if those bottom portions die, new ones start to grow on top of it and build the reef bigger and bigger. Now, unfortunately, coral is having a lot of problems on a global scale. Coral around the world is starting to really struggle, and there's a lot of problems facing it, but there's kind of two main ones. And it's mostly, well, it's 100% caused by humans. Most of the problems that humans are causing for coral happen here on land. The biggest being climate change. With climate change, we're using too much energy and we're creating pollution and adding a type of gas into the air called carbon dioxide. Carbon dioxide acts as a blanket that causes the whole world to get warmer. Recently, the last like 20 years, I think it's like 16 of the last 20 years have been the hottest years that have been recorded by humans. So continually, we continue to be very warm and going up in temperature. And in addition to temperatures on land, it's actually heating the oceans up too. Most places, the ocean temperatures have gone up 2 or 3 degrees in the last 30 years or so. And with that, animals like coral are really struggling to adapt. Some places they're doing okay, a lot of places they are not. When they feel stressed and things like warmer temperatures cause them to bleach. Now let's talk a little bit about bleaching. The corals feel stressed. They have this weird zooxanthellae, this algae living inside them, kind of like lettuce growing through your skin. And when they're stressed, they're like, you gotta go. They kick the algae out. The algae is important. It provides food for the corals and it helps them to live. If the stress continues, if the water temperature, if it's heated up, if it continues to stay hot, then that coral will die. That coral will usually die if it doesn't get its algae back within a couple months. Then it starves to death, essentially. Now, it doesn't always kill it when it bleaches. It sometimes is able to recover. So there was an incident that was very well studied in the Indian Ocean, over by India, in 1998. So a bit ago, not too long ago. During that coral bleaching, 80% of the coral in this study site bleached, or it turned white. It kicked out its algae. And over the next couple months, most of those corals were able to recover and the algae came back and the reef survived. But 20% didn't. 20% died. And when the coral dies, the reef starts to break apart. And then all of those homes that it provides to many, many other animals, they don't have a home anymore. And any of the protection it provides to the shoreline of neighboring islands or coastal areas, that also isn't there anymore. And any of the fish that the people eat that lived around that coral, those fish are now gone. Those people no longer have those fish to eat. So coral and its success really impacts many, many other species, including us, including people. And so it's within everyone's benefit to help coral out. So climate change is one of the big threats that's threatening coral. Another one is called ocean acidification. With any substance on Earth, scientists assign it a level called pH. They kind of help measure things that are like, is it more acidic or is it more basic? And everything gets a number assigned to it. Water is right in the middle, regular fresh water, right in the middle. Everything else is either more acidic or more basic than the water. The oceans are continuing to get more and more and more acidic. Seawater is already a little more acidic than fresh water. And when ocean acidification, when it gets more and more acid, that causes the corals to not be able to build their little calcium carbonate skeletons anymore, their little rocky-like homes. And in some places, if the ocean has gotten really acidic, those actually start to deteriorate and break apart. And then the coral doesn't have its little safety to protect it, and it starts to die. So ocean acidification is a huge problem as well, and in some places, typically around areas where there's big cities or rivers that come into the ocean that are near cities, this is where ocean acidification typically happens. Ocean acidification, as you may have guessed, is caused by people. And it's caused by people with chemicals that come from the land and end up in the ocean. And they cause the acid level of the ocean to rise. And then the corals and other animals struggle and suffer and die. Ocean acidification is caused mostly by things like fertilizers, poisons, and toxic chemicals that are related to like industries. So whenever they're like making fabric and dyeing the fabric, or if they're making gasoline or oil, or if any of those spill, that can help cause ocean acidification. And when those chemicals get in the water, it kills a lot of different animals and causes a lot of problem. But in general, the entire ocean is all, because it's all connected, right? We talked a little bit about this yesterday. We call it the Pacific Ocean and the Atlantic Ocean and the Indian Ocean and the Arctic Ocean. But if you look at a globe, they're all connected. All the oceans are connected. So even if a problem happens across the world, say near China, it can impact the ocean, say in Hawaii, or it can impact the ocean here in California. And eventually it can impact the ocean everywhere. because they are all connected. That water moves around with currents, and it causes those problems to spread. Another problem that coral has, this is specific to areas where there's a lot of rainforest destruction, places like Indonesia, Malaysia, Brazil, Madagascar, places where they cut down a lot of the trees. Trees provide a huge service to the rest of the world. They hold the earth together. The roots of trees help hold the earth in place. If you cut down the trees, the next time it rains, a lot of the dirt runs into the river. In places where they're cutting down the trees really fast, like those countries I listed, Indonesia, Malaysia, Brazil, Madagascar, those places, their rivers aren't clear anymore. They run like mud because there's so much dirt and other things that are in the water on the way out to the ocean. And if that gets out into the ocean where there's coral reefs, it causes a cloudiness in the water to where the sun can't filter down to the algae that's living in the coral, and that causes problems as well. So we've talked a lot about problems that coral reefs are experiencing, but there's a lot of people doing a lot of good to help out too. Our special shout out today is to an organization called Seacorps. I'll be sharing some of their information later on the Facebook page, but they are a worldwide coral reef conservation organization, and they study through research, education, outreach, and restoration. So these people are actually helping sick and injured coral reefs. What they've done is they've learned that some reefs, especially really close to the equator, are super resilient to things like the ocean temperature change. And some coral reefs that have been in place for a really long time are also a little more resilient to ocean acidification. And so what they're doing is they're studying the coral species that live in those areas and how are they successful in adapting quicker to rising temperatures and rising acid levels. And then they're studying those species and what those species need. And in some places they're helping to collect those species and then put them in places where other ocean or other coral reefs have been damaged. So that brings up an interesting topic that I also wanted to talk about, and how coral reproduces. Coral can reproduce a multiple number of ways. So in the animal world, there's sexual reproduction. That involves both a male and a female of the same species, and they both contribute something that helps cause babies to be born. And then there's asexual reproduction. We don't know as much about that because it's not something humans do. But some animals, including coral, can do that. And so as they're growing, if my fingers were coral that were growing, and maybe this coral and this coral got really close, and then a big wave comes and breaks those, the pieces can fall down. Sometimes they can land and reattach and continue to grow from down over here. So that is something called fragmentation. If something can break off and then start growing again, that's called fragmentation. That's asexual reproduction. Coral is capable of doing that. And organizations like Seacorps have studied those special supercorals that do really well, and they found out ways to help conduct things like fragmentation to move some of those little corals that have broken off maybe during a storm and put them in places where the reef is damaged or hurt or sick or dead, and those little baby corals can help grow and cause the reef to get a little healthier. Now, coral can also reproduce by something called budding, and that's where if it gets really, really big and there's two corals and they're getting really close together, it can actually separate and become two different identical corals. That happens when there's really healthy environment around, there's lots of food for the corals are doing really well. Some other animals can do this as well. I talked about that, I believe, a little bit in the sea stars critter chat. Sea stars are capable of reproducing through budding or splitting in half. Corals can do that as well. Now, corals also produce sexually, and they produce sexually like fish produce sexually for the most part, called spawning. And what that means is that the coral living over here may be some girl coral, and the coral over here might be boy coral. And they both shoot their gametes out into the water, and those meet up, and then they form little tiny larva coral that kind of float in the plankton and eat the other plankton for a little bit. And then as they get bigger, they settle down and become new coral further away from their parents. And scientists working with organizations like Sea Corps have figured out how and when corals spawn. And they will often go to those reefs that have the super corals that are really resilient to ocean temperature change or ocean acidification, and they'll collect those little spawning corals and help bring them back into a captive setting and help them to grow under the perfect conditions. And then when they get big enough, they can take them back to the ocean and put them back in places where coral reefs are sick, injured, or dying. And Sea Corps has done a lot of really great work in doing that. Now, during my time at the Aquarium of the Pacific in Long Beach actually works as a partner with Sea Corps and has helped to do that. People from the aquarium have gone to spawning events with coral and helped collect some of those little baby corals to bring back and raise at the aquarium and figure out what exactly those different species need as far as sunlight, nutrients, pH levels, all of those things to help them grow in ideal conditions so that they can grow a little faster and be healthier and be returned back to the ocean at a later date in time when the little corals get big enough. They also do a lot of work at the aquarium with fragmentation. So I saw that a lot where some corals that had gotten broken, they could then help get them started in new places so that they could grow up little baby corals into bigger corals that could also hopefully someday be reintroduced. Now, the Aquarium of the Pacific also has, like the video I showed earlier, the corals in that are actually fake. The aquarium didn't want to ruin a bunch of real reef out in the ocean. It was only built 21 years ago, so they built it with fake coral to show what coral looks like, but without taking apart a whole big reef and causing problems out in the real ocean. They used fake coral, but they do have some live corals there too, and I'll share some videos of some of the live corals that the aquarium had that I took when I worked there. They're a bit smaller, so they don't have a huge reef of live coral yet, because again, the aquarium's only 21 years old, and coral takes a long time to grow. I've also experienced coral when I vacationed, specifically to Hawaii. And during my time that I lived in Hawaii, I was able to explore coral reefs quite a bit. It's one of my favorite things to do when I go to a place like Hawaii, where there's a lot of coral around all of the islands. And particularly, there's a huge protected area of Hawaii that most of us have never been to. And it's kind of past the other Hawaiian islands that we know, in the older Hawaiian islands, and it's called the Northwest Hawaiian Islands, and it's a marine protected area. And a number of years ago, the US government set that aside as a big ocean sanctuary. And the coral that is growing there in that area of Hawaii is a very important scientific study, and a lot of people are learning a lot about the corals so that we can continue to help corals out from far away. We can also do our part in helping corals out. One is by limiting the amount of energy we use. Turn off the lights when you leave the room. Try to go to all the stores that you need to go to when you go out shopping, instead of driving from your house to Target and then driving from your house to like the hardware store and then driving from your house to the grocery store. Go to all of them at once. Get it all done at once. That's less gas you're using. That will save you money, but it also helps save the planet and limit our climate change. Another good thing that you can do is when you're buying sunscreen, try to make sure your sunscreen is reef safe. A lot of sunscreen out there has chemicals in it that can hurt coral. And so check on the label of your sunscreen to see if it's a reef safe sunscreen. And I encourage you to try to buy that when you can. I hope you've enjoyed what I've shared with you today about corals. I have a lot of additional material and some beautiful videos that I'll be sharing later today on the Facebook page, so make sure you check those out. And as always, feel free to like, share, subscribe, and follow to all of my Zoo Nerd information on Facebook, Instagram, and YouTube, and on my website at jeremythezoonerd.com. Until tomorrow, enjoy, be happy, be safe, be healthy. I'll see you tomorrow. Bye.